This is designed to teach students how to design a working project with electrical hardware and run a programming language called LabVIEW. The elevator trainer is shown to the right that will be programmed. It has 14 push buttons, various different components. My Rio is used to operate the elevator, which is shown in this particular picture here, and it has a bunch of different digital outputs. The only analog inputs used was for the photo floor sensors. The DC motor is shown to the left. This is what actually operates the carts up and down, and the encoders are used by the motor controllers here. This is what actually keeps count. Your floor sensors are shown here, which is what if it's less than 2 volts, it would stop the elevator. If that was the floor you wanted to stop at, that's your pneumatic cylinder switches. They open and close, which we actually didn't even use these. The doors open as far as they'll open and close as far as they'll close. The pneumatic solenoids are shown right here. 2 solenoids are used for each door, one to open, one to close. 14 push buttons for the elevator, and as you see the blue doors, the UART used to control the elevator. Since we wasn't there in class to operate the elevator, we used this UART. Each button had a set value. This is my elevator program used to operate the elevator trainer. UARTs are used to read the push buttons on the UART. Moving to the first floor, this small VI right here, in this particular case, let's move back to the default, moves it to the first floor, but it also reads and sees which one has the least amount of calls, and that's the elevator that goes to the call. Say if one had 2 calls and one had 1 call, the one with 1 call would go to would take over, and each elevator light is set true or false, and no, just true. It cuts on in this particular. This is the red elevator. Like I say, the call buttons are the ones that use the small VI. The inside elevator buttons don't need the VI because they don't have to make a choice. You're inside that elevator, so that's the only buttons you can use. Move to the first floor, second floor, third floor. Have your yellow elevator, which is the same thing I just explained for the yellow elevator. So let's move down here to the actual movement of the elevator, the doors, and the motor. You first start the program. I have this film clip over here that actually takes and raises the elevator up for 2 seconds to make sure that it comes up above the floor sensors, because if the floor sensors aren't made, it won't even start. So to ensure that, the elevator goes all the way down to the first floor, cuts all the LEDs off, and resets the encoders on this particular initialized button. And if no buttons have been pressed, it's going to stay in idle. This is your move to the first floor. It actually cuts off the LEDs once it moves to the first floor. Your move to the second floor, move to the third floor. Your open first floor door. This is tells it to open the door, and it actually has a timer. It's the same for all the doors. They each have their own case, and then this is the timer 1, timer 2, and timer 3, which will keep the doors open for 5 seconds. And then you have your open second floor door, third floor door. So this is actually your open, which you also have timers in there too. As stated a minute ago, they stay open for 5 seconds, and both of the elevators have the same thing, except the push buttons are set a little bit different. Your motor counter values down here at the bottom, and your floor positions are set by the values of the encoder. That's why it's important to have your encoder reset at the start of the program. That way you know your numbers are counting correctly. Minus 299 to 100 would be the first floor. 7,999 to minus 300 is your second floor, and minus 20,000 to minus 8,000 is your third floor. And that is a quick overview of how the elevator trainer program is used to operate. I wanted to show you how the elevator trainer works once it has been programmed. I just cut the program on, and as you can see, the elevators both lift up then go down, which is basically homing itself. They lift up to ensure that the sensors will be made on the bottom floor, say if it was sitting below the sensors on this bottom here, it would lift it up to where it would read a sensor. So let's hit the third call button. As you can see, it lights up and the yellow elevator goes up. Let's hit the second call button. You'll see the red elevator goes up. As you can see, it reads the third floor on the yellow floor over here on the display, and the door opens for 5 seconds. As you can see on both of the timers, it's actually waiting on us to hit the inside button. We'll send the yellow one to the first floor. We'll send the red one to the first floor, the yellow one to the second floor. Let's hit some of the other call buttons. Let's go the third floor, which the red should go up. No, actually the yellow one went up there. So we'll hit the second call button, the red went up. We'll hit the both inside buttons to go the second and the third floor. We'll hit the third floor for the red one. Once it goes to the third floor, we'll hit the first floor. It should go down, and we will hit all the call buttons. Let's say someone's standing outside and wants to, elevators are very busy now. So the first floor gets on, goes to the second floor, and then we'll say the red one, it goes to the second floor. They both stop because both call buttons were pressed to go up or down. So we'll send the red down, the yellow's going up to the third floor. And I've got it set up to where both LEDs cut on when you hit, just like it would on a regular elevator. You'd be able to go to either elevator, whichever one gets there first. But as you can see, all of the LEDs work properly, and both elevators function simultaneously. Whichever one has the least calls goes to whichever floor it needs to. But that is how my elevator works. Thank you. The elevator was working as closely as possible to an everyday elevator. The push buttons work properly on both elevators. The UART called the appropriate buttons. The elevator closest to the floor called responding accordingly. Each elevator had to be handled separately, which was tough. A queue had to be used to operate the elevator when multiple push buttons were pressed. There were 14 different cases used to operate the 2 elevators. 7 buttons for each elevator, and 2 elevators equal those 14 cases. The first floor was set between -299 and 100 for each encoder reading. The second floor had its own values, and the third floor had its own values. The elevator took much longer than I expected to program because it was tough to get both of the elevators working together, to have the one that was already in motion, the one that wasn't doing anything while the other one was in motion, to take over and go to the appropriate floor. That took me the longest to get working properly. It makes me have a much better understanding of how all the components in the program works for an elevator, and I definitely have much more respect for elevator technicians. I hope you enjoyed my video, and have a good day.